Recording has
So for the first one, bless you. So for the first one here, solving for x. Now remember, we need to, before we can solve, we need to make sure we combine what we can on either side. Nothing to combine here. And we need to make sure that the variable's on only one side, and it's only on one side here. So we can go ahead and solve. So we'll add 9 to both sides to get rid of the minus 9. So 4x equals 27 plus 9 is 36. And then the 4 is multiplying x, so we get rid of it by dividing. So we have x equals 36 divided by 4 is 9. Number 2, again, combine what we can on either side. Well, there's nothing to combine here. 2, make sure the variable's on only one side. Well, the variable is on both sides here. So we're going to get rid of one of them. 3x is the smaller one. It's positive, so I'm going to get rid of it by subtracting 3x. I have to subtract 3x from the other side as well. I can only add or subtract things that have the same name, so I have to subtract it from the 5x. So on the left, all I have left is the 7. 5x minus 3x is 2x, and I have the minus 9 there yet. Now I'm ready to solve. I'll add 9 to both sides, giving me 16 equals 2x. And then x is multiplied by 2, so I'm going to divide by 2, get 8 equals x. Number 3. Again, first step, combine on either side. Well, here on the left side, I can combine the 5x and the negative 3x to get 2x. Still have the minus 5 there. Equals 19 on the other side. So I've combined everything I can combine. The variable is already on just one side, so we'll solve. X has been multiplied by 2, then 5 has been subtracted. So to solve it, I'm going to add 5 first. Get rid of the minus 5. 2x equals 19 plus 5 is 24. Now I have to divide by the 2. X equals 24 divided by 2 is 12. Now, of course, for all of these, I could go back to the original equation and double check. I could go back up here, replace x with 12. So 5x would become 5 times 12, minus 5, minus 3x becomes 3 times 12, equals 19. And double check to make sure I get 19 on the left side to match my 19 on the right side. Order of operations says I'll do 5 times 12 is 60. Then I'll do 3 times 12 is 36. 60 minus 5 is 55. And 55 minus 36 is 19. So I do get 19 on both sides. So that verifies that answer of x equals 12 is the solution to that equation. Well, there's a next step we can take. Looking at combining things on either side of the equation, we can run into things like this that need to be combined. Whenever we see parentheses in a math problem, it should scream at us to do something here first. First thing we should check is to see if there's anything to do inside the parentheses. And in this case, there is not. 2x minus 7, that cannot be combined. Next, we should check to see if there's anything that needs to be done to the parentheses. And here it's being multiplied by 8. Now, the way that gets done, I'll write it off to the side here, 8 times 2x minus 7. The actual way, the long way of doing that, is to write it out just like a regular multiplication problem. 2x minus 7 is just a 2-digit number multiplied by 8. 8 times negative 7 is a negative 56. 8 times 2x is 16x. We get 16x minus 56. But writing it out like that takes up some space and some time. And we have to rewrite the whole problem off to the side. So there's a shortcut that most of us, if you've had pre-algebra or algebra, you learned is called distributing. Within the problem like this, you just take the 8, and you're going to multiply each piece inside the parentheses by the 8. So you do 8 times the 2x is 16x. 8 times the negative 7 is negative 56. Notice you get the same answer. It's just a little shorter. We didn't have to rewrite the whole problem and all that. So over here, that's exactly what we do. 8 times the 2x is 16x. 8 times the negative 7 is negative 56. Now, there is nothing more to combine on either side of that equation. The variable's already on one side, so we'll go ahead and solve. X has been multiplied by 16, then 56 has been subtracted. Take it apart. We'll start by adding 56. So that minus 56 is gone. We have 16x equals 24 plus 56 is 80. And now the 16 is multiplying x, so we get rid of it by dividing by 16. X equals 80 divided by 16 is 5. Now, every now and then a student will ask, couldn't I have just divided by 8 up here and got rid of the 8 instead of multiplying it out and working with the large numbers? In this case, that would have worked fine. The problem is it's not always the case. We run into problems like this where that wouldn't work. We can't just divide by 5 here. But we can go through our process, combine what we can on each side. Well, the right side's just 56. Obviously, there's nothing to combine there. But the left side has some things we can work with. First, we see the parentheses. Dream, do something here first. Nothing we can do inside the parentheses. So we'll distribute the 5. We'll multiply by the 5. 5 times 3x is 15x. 5 times 1 is a positive 5. Now we still have the plus 2x there. And we still have things we can combine on that left side. 15x and 2x makes 17x. We still have the plus 5. That equals 56. Now we've combined everything we can combine. The variable is on only one side, so we can go ahead and solve. Subtract 5. 17x equals 51. Now we'll divide by 17. X equals 51 divided by 17 is 3. So we get x equals 3. Now, just like before, we could double check if we wanted to. 5 times 3x becomes 3 times 3 plus 1, plus 2x becomes 2 times 3, and check to see if that comes out to be 56. Well, now it's an order of operations thing. 3 times 3 is 9, plus 1 is 10. 5 times 10 is 50. 2 times 3 is 6. 50 plus 6 is 56. So I do get 56 on both sides. So we might have one that looks like this. I'm going to have you try that one in your notes quick. See what you come up with. We'll give you about a minute, then we'll go over it. So, on the left side here, we see the parentheses. So we start there. Nothing to do inside the parentheses. So we're going to multiply by the 3. 3 times 5x is 15x. 3 times negative 11 is a negative 33. We still can combine the negative 33 and the negative 8 here. So we have the 15x, negative 33, and negative 8 makes a negative 41 equals 64. Now we can solve. We'll add 41. So we've got 15x equals 105. And we'll divide by 15. X equals 7. I'm not going to go back and plug it in, but we could go back and plug that in for x and verify that we get the same value on both sides. At this point, I'm going to assume you guys can go back and plug it in to double check it. Well, every example we have done so far has been either a single set of parentheses or just stuff to do on one side. First, before we get too much more complicated, we need to look at what happens when we run into something like this. Now, this looks relatively simple, but there's one very big complication here. That is the minus in front of a parentheses. Whenever there's a subtraction in front of a parenthesis, we have to be very, very careful how we handle it. In fact, the easiest way to handle it is to think of it as negative 1 times that parentheses. So let's do it that way. So here, we need to combine on the left side. Nothing to do in the parentheses, so we're going to multiply by the negative 1. I'm just going to bring down the 2x. Negative 1 times 5x is a negative 5x. And negative 1 times negative 1 is a positive 1. I can still combine on the left side there 2x and negative 5x makes negative 3x. So still have the plus 1 equals 16. Now we've combined what we can combine. The variables on one side. We're ready to solve. So we'll subtract 1. Negative 3x equals 16 minus 1 is 15. And I can divide by negative 3. I get x equals 15 divided by negative 3 is negative 5. So I had to be careful with that negative in front of the parentheses. Now we can have multiple parentheses within a problem. Like this. We have two sets of parentheses on the left side there. So, order of operations tells us we work left to right. First set of parentheses, nothing to do inside. So we're going to multiply by the 7. 7 times 2x is 14x. 7 times negative 5 is a negative 35. Second set of parentheses, there's nothing to do inside there. So I'm going to multiply, but not by 2. It's actually a negative 2. Negative 2 times 3x is a negative 6x. Negative 2 times 1 is a negative 2. Let's complete. There's more to combine here, so let's finish combining on the left side. So 14x and negative 6x make 8x. Negative 35 and negative 2 makes a negative 37. On the right side, there's actually nothing to combine. Just 3x plus 13. Now, however, there's a variable on each side. We have to get rid of one. 3x is the smaller one, so I'm going to get rid of it. It's positive, so I'm going to subtract it to get rid of it. Remember, we have to subtract 3x from the other side as well. So on the left side, 8x minus 3x is 5x. Still have the minus 37 there. Equals. On the right side, the 3x cancels out. I just have 13. Now we're ready to start to solve. We can add 37 to both sides. 5x equals 50. Now we can divide by 5. X equals 10. I'm going to have you try one in your notes. Give that one a shot. We'll go over it in just a minute or two. Okay, so here we start on the left side. We can combine with the parentheses. First parentheses, nothing to do in there, so we're going to multiply by the 2. 2 times 5x is 10x. 2 times negative 4 is negative 8. Second set of parentheses, there's nothing to do inside there either. Looking at the outside, we have that negative in front, that minus in front, so that means we're multiplying by a negative 1. Negative 1 times 3x is negative 3x. Negative 1 times 2 is a negative 2. We can still combine here on the left side. 10 and negative 3 is 7x. Negative 8 and negative 2 is a negative 10, equals 4. Now we're ready to solve. We'll add 10. 7x equals 14. And divide by 7. X equals 2. Well, these can get more complex. For example, give yourself a lot of room if you're writing this one down. We can have parentheses on both sides of the equation, like this. Doesn't really change our approach. We're going to start on the left side, combining what we can combine. Nothing to do inside that parentheses, so we're going to multiply by 3. 3 times 5x is 15x. 3 times negative 1 is a negative 3. Here, negative 2 times 3x is negative 6x. Negative 2 times 4 is a negative 8. Let's keep combining on the left side while we're over here. 15x and negative 6x is 9x. Negative 3 and negative 8 is negative 11. We have now combined everything that we can on the left side. Let's go to the right side. First set of parentheses, nothing to do inside there, so we're going to multiply by the 5. 5 times 2x is 10x. 5 times 7 is 35. Next set of parentheses, again, nothing to do inside there, so we're going to multiply by the 2. 2 times x is 2x. It's a positive 2x, so I'm going to put a plus in front of it. 2 times negative 3 is a negative 6. And I still have the plus 2 there. Now combining what we can combine, 10x and 2x make 12x. 35 and negative 6 make 29, plus 2 is 31. Now we have variables on both sides of the equations. We need to get rid of one. 9x is the smaller one. I'm going to subtract 9x. So the 9x is gone on the left side, leaving me with negative 11. On the right side, 12x minus 9x is 3x. Still have the plus 31. Now we're ready to solve. So we'll subtract 31. Negative 11 minus 31 is a negative 42. So negative 42 equals 3x. We're going to divide by 3. Negative 42 divided by 3 is negative 14 equals x. So x equals negative 14. Now these problems can get difficult in other ways. We can run into things like 3/8 x minus 5 1/4 equals 6 1/2. To solve this is just like solving any other equation, only we have to deal with the fractions. We have to add 5 1/4 to both sides. To make that go away, that leaves us with 3/8 x. Well, on the other side, we got to do our common denominators. It's going to be 4. 6 1/2 will be 6 2/4. 5 1/4 will stay as it is. 2/4 and 1/4 will be 3/4. 6 and 5 is 11. This will be 11 3/4. Then I need to divide by 3/8. So that'll give me x on the left side. I have 11 3/4 divided by 3/8. First, I change the 11 3/4 to an improper fraction. So 11 times 4 is 44, plus 3 is 47/4. And then I'm going to multiply by the reciprocal, times 8/3. 4 and 8 both divide by 4. 4 divided by 4 is 1. 8 divided by 4 is 2. Multiply, 47 times 2 is 94. 1 times 3 is 3. And I reduce. 94 divided by 3. Well, 3 goes into 9 3 times. That's 9. There's nothing left over. Bring down the 4. 3 goes into 4 once. That's 3. There's nothing left over. So that is 31 1/3. It looks like a different process because we have to deal with all these operations with the fractions. But it's the exact same process as solving something like 2x minus 7 equals 11. You just add and then divide. But we have to work with the fraction. We can run into something like this. 2.1x minus 4.7 equals let's see here. 2.2. Let's go with that. So, to solve this, we're going to add the 4.7. 2.1x equals 2.2 plus 4.7 is 6.9. Then we have to divide by the 2.1. We get x equals what is that? 3.285714286 approximately. Well, that's an ugly decimal, and actually it keeps going forever and ever. It's a repeating decimal. I just rounded it off after 9 decimal places there. Is there a better way to express that answer? Now, if you do this, I'm not going to mark it wrong. But from this division here, we can get an exact answer. We can get a fraction. Fractions are exact answers. Decimals often are rounded. We had mentioned when we talked about fractions that fractions and division problems, it's easy to jump back and forth from one to the other. So we can treat this division problem like it's just a fraction. 6.9 over 2.1. We need to get rid of those decimals. There's 1 decimal place in each. We'll multiply by 10. 6.9 times 10 is 69. 2.1 times 10 is 21. And now we can reduce. Now, first of all, 6.9 and 21 can both be divided by 3. Sorry, 69 and 21 can both be divided by 3. 69 divided by 3 is 23. 21 divided by 3 is 7. And now we can reduce that. 23 divided by 7. 7 goes into 23 3 times. 3 times 7 is 21. There's 2 left over. So that's just 3 2/7. As a fraction like that, that's much more exact. That is exact where the decimal is rounded. We can run into problems that look like this. This looks like a fraction, but it really is not. We ask what's been done to x here. Order of operations, remember these fraction bars tell us you have to do everything on top first. So x was multiplied by 3, then the 7 was added. Then you do everything on bottom. Well, there's nothing to do on bottom here. Then you divide. So the x was then divided by the 4. So it just adds a step that was done in building this equation. So it adds a step we'll have to do to take it apart. Remember, we take off the last piece that was put on first. That was dividing by 4, so we're going to multiply by 4 to take that piece away. Remembering to multiply by 4 on the other side. 3x plus 7 equals 7 times 4 is 28. We will now solve it. Subtracting 7. 3x equals 21. And dividing by 3. X equals 7. Okay, I've hit the point where I want to give you work time here. So I'm just going to give you the first page worth of homework here today. Page 253. That's exercise 6.3. 1 through 59, the odd. We'll talk more about these equations tomorrow. The way it looks is next Tuesday, we're going to have a quiz, and it's going to be a longer quiz. So what I think I'm going to do is I'm just going to give you the whole day next Tuesday to do the quiz. So for those of you that have other things going on and can't necessarily be in class at a specific time, I'll have that quiz posted by the end of the day tomorrow. So as long as you get the quiz done, you'll have met your requirement for next Tuesday. I will still log into class Tuesday at the beginning of class in case anybody has questions on the quiz or wants help on the quiz or questions on any of the homework from the last several weeks. But there will not be a new lecture next Tuesday. It'll be dedicated to taking the quiz and answering any questions. Anybody that needs corrections on tests or quizzes that they want help with, I can help you with that. That's the way we're going to handle next Tuesday. So with that, I will shut off the recording here. If you want to get started on the homework, I will be here on the network to answer your questions. Otherwise, have a great day, and we'll see you tomorrow.
All right, you too.
Thank you.